Last time we looked at our 383 block, I promised you guys I'd show you how we relieve the block. So the first thing we do is we need to put a couple of bearings in. So these are main bearings, and you want to put some oil on these. You really don't want to lay your crankshaft on totally dry bearings, so you don't need a whole lot in here, but just a little bit of oil on each bearing. Once you get that done, you can lay your crank down in the engine. Remember, this is our stroker crank. We haven't really done any relieving. Now I've made some white marks on the block. You can see with a metal marker there. I do that. Those are the areas where I think, just from past experience, I may have to do some relieving. But what I actually do is once I get the crankshaft in, then I take a red marker and I look very closely at some of these areas where I think the crank throw is a little too close to the block, and I will actually mark those in red, and that's where we're going to go in and do our cutting. So the crankshaft throws themselves, you really don't have too much interference problems here. We just want to relieve some of these areas that are kind of close and make sure that everything is, nothing is gonna hit here. So I'm going to mark all these areas. Once we get that done, then we can start thinking about putting our pistons in. Now, you need to put each piston in its respective cylinder along with its connecting rod. So obviously, the first thing we're going to do is we have to put our bearings in the big end of the connecting rod. So we take our bearings and we put them in the big end. And the same thing holds true as far as lubricating these. You really don't want to let these bearings ride dry on that crankshaft. So we take a little bit of oil here and we just put a few drops on there. It doesn't take much. Same with the connecting rod here. We're going to put a few drops on. That way when we put this in, we don't have metal to metal contact. So now obviously this is not the final assembly of the engine, but we are putting new components in, and so we want this, we want it to be as clean as possible. We're also going to take one of the thrust bearings. This is the lower thrust bearing. We're just going to put it in the cap. If you look at the engine here, you can see I don't have the upper bearing in. You can use the upper or the lower, it doesn't matter. Because I've already got the crankshaft laid in there, we're just going to put the upper bearing in. And this is going to locate the crank and give us a good idea of where it's actually going to ride. So you want to put this cap on and make sure you seat the cap, get the bolts started. Just take a soft hammer and seat it, make sure it's down. And then these bolts don't have to be tight. We can just hand tight or finger tight these in. So get them down finger tight. And it gives you a good starting point, good steady support for your crankshaft. Well, now that we got the crank in and we've kind of relieved a little bit of that, we want to start putting our pistons in. But before we do that, the block's been sitting around the shop, even though it has been vatted and cleaned and magnafluxed and all that stuff. It's probably got some dust that is settled on it, maybe some dirt on those cylinders. So we want to wipe those off. We want to take a towel, and it's probably a good idea to take some spray oil like some WD-40 or even some light engine oil in there, and just wipe these bores out really good, because we are going to put, like I said, a new piston in, 4 new pistons in each bank. And so once we get this cleaned out, the next step is we want to install. We're actually going to install every piston in the engine. This is the pre-assembly process. This is not the final assembly. We're going to have to install every piston in every hole and every connecting rod, and then rotate the engine, and we'll look and see what kind of clearance problems we may have, because with a longer stroke crank, and we're not going to put the rings on or anything like that, Now we do have the rod studs here. You got to be careful with the rod studs. We want to use a journal protector. I've got this horseshoe shaped journal protector here, and this just goes over the studs like this. So what we do is we take and we put our journal at bottom dead center, and then you're going to just put this horseshoe shaped journal protector in here. You can use fuel line or whatever else you want. This journal protector came from Powerhouse. I really like it because it actually acts as a guide for the connecting rod. Also make sure that the valve reliefs are facing the lifter valley, and make sure the tang on the rod is going to go to the outside on a Chevrolet. So make sure the orientation of the piston and rod is correct. Then we just kind of fit the studs in here to the journal protector, and very carefully kind of work that piston into the cylinder bore. Just give it a little nudge there. Once the piston goes in, then we just push it down to bottom dead center with our journal protector. Notice how that journal protector really does a good job of protecting that crank from those hardened rod bolts. And we don't want any nicks or scratches or anything. Then we're going to take the rod cap that obviously goes on that rod. Make sure it's in the right orientation. Don't put it on backwards. And we're going to put this on. You don't need to really torque this connecting rod. You can just get those bolts, snug. And then we're going to rotate our engine, and we're going to look at how close this connecting rod comes to different portions of the block. The connecting rod may come very close to the pan rail on some of that nut, connecting rod nut, and here we were pretty close. So I'm taking a red marker and I'm marking the spots where we're too close. You need to have at least 100 thousandths clearance between that rod or the rod bolt and any portion of the bottom of the block. On this side, our rod nut was way too close to the block, so we're going to have to go ahead and mark it, and that's where we're going to be doing some cutting in there. So you want to rotate this all the way around 360 degrees. Also put one rod in at a time. Now we're looking through the camshaft tunnel here, and the reason that I don't put the cam in and the reason I only want to put one rod in at a time is because I take a peek through the cam tunnel, and as I rotate the engine I look at the upper portion of that rod bolt, because in some places inside the block that rod actually comes very close to actually too close, and it could actually hit some of the casting inside the block. And so we have to do the same thing here. We have to visually inspect as we rotate that, and we have to mark the block where it needs to be relieved. This one here looks really good. Sometimes you have to worry about the rods hitting the camshaft as well. With this build we're using a camshaft that has a small base circle, so we're not really worried about hitting the cam. The cam's designed to work with the stroker. So you want to do a really good visual inspection. You may have to get some type of a light. You want to get a good one, and we look at every single portion of that rod as it rotates to make sure that we haven't, anything that needs to be trimmed off there, we can mark it and trim it. And of course we're going to continue that. You need to do every rod. So here we got the next one in here, and we're doing the same thing. We're going to continue this process. I'm not going to videotape the process of inspecting and marking every single connecting rod here. That would be quite a boring video. But again, the process is one connecting rod at a time on each bank, and you have to do all 8 of them. Now on this one here, boy, we really had, if you see this, we're actually hitting the block here. You can see where I've marked it with red. We're going to have to do a considerable amount of clearancing there. If you were to put this together without doing this, you'd have a major engine catastrophe on your hands. Like I said, everything when it gets hot it expands, and so we need at least 100 thousandths of clearance between all these parts when they're cold. And we're definitely going to have to do some trimming on this one. Hope hopefully that's obvious to you that you wouldn't want to run that like that. So we're going to do that for every connecting rod. Once we get that done, and I've also marked each connecting rod that I've done. Once I put a rod in and I just put a line in line with that particular rod, that lets me know that I've already checked the clearances and marked everything. And just a reference for me. It helps me remember where I'm at and what I'm doing. So once we get all of the inside of the block marked, we can start cutting. Now you need to make sure that you protect yourself. These particles and chips are not good to breathe. It's a good idea to use a respirator. Also, you need to have very good eye protection that covers 100% of your eyes, even the peripheral sides. If you're using a vacuum and an air compressor and so forth like I am, ear protection as well, and gloves. So you need to protect yourself. I have a 6500 CFM Master Cool on my shop that constantly blows a massive amount of air through and pushes everything out. Plus I have a large fan that I also push up. You can see it there behind me. I will push that fan up right on the work. And I have a vacuum. I take my shop vac and I just use a clamp on the bench and I will put my shop vac. You can see how that big fan is blowing on me there, because I don't want to breathe any of this stuff. Not only do I not want to breathe it, I don't want it in my face or down my shirt, around my arms. You don't want to breathe any of these metal shavings. They are not good for human beings, trust me. Also, I had a problem where I've had metal in my eye and had to go to the eye doctor and take it out. That's why you need to use the eye shields that cover your entire eye. Turn your shop vac on, make sure your fan's blowing, make sure you got all your protective gear on, and then we just take our die grinder. I like to use the electric die grinder because I don't want to. I have pneumatic die grinders, but they're really hard on the compressor. So the electric die grinders work great with a grinding stone or a cutting tool, and then we just go out in and we start relieving these areas that I marked with red. This is the first relieving process here. Now I will be nice to you guys, and I won't shoot video of the entire deburring process because it takes several hours to actually get this right. So this is about 3 hours later, and if you see, I've gone and all the red marks that I made are gone. So what I've done is all the areas I marked red, they've been relieved and ground down. Now this may not be the last time we have to do this. You know, you're kind of guesstimating at how much to take out. You don't want to take off too much material because you don't want to, you know, punch a hole into the cooling system, or, you know, you don't want to do any damage to the block. So also on the end of the block, this is the front where the double roller timing chain is going. It's a good idea to tap these holes with a pipe plug and relieve that boss up there. Also, I usually open up the oil holes because I want to have good oil drain back on the block. So relieve the front of the block for the timing chain, and if you look here, you can see all of the relieving that has been done to this block. Now the block is very dirty. We need to put our crankshaft back in and recheck all these clearances and possibly grind it some more, but there's no way we can do it. So we need to wash it. You need to thoroughly wash all of the grinding material and the iron filings and everything. You need to just really, you don't need to final wash it as if you were final assembling it, but make sure you get a good blast of water through all the oil galley holes and just do a very thorough wash down of this block, because we really don't want to put our crankshaft bearings or the crankshaft or rods or anything back in with all kinds of grit in this block. So it's pretty imperative that we wash everything, and that way it assures that we don't have any problems with metal particles damaging our bearings or our crankshaft surface. So wash this baby down really good, do a very thorough rinse down. Once you get that done, very important to note that this block will rust very quickly. If you have a leaf blower, I discovered the use of a leaf blower by mistake. One day my compressor was off and I needed to dry a cylinder head, so I just grabbed this thing. To my surprise, the leaf blower actually dries heads and blocks much faster than the air hose does, and I've been using it ever since. Very important, you have WD-40 handy. All the machine surfaces immediately need to be sprayed down with WD-40. If you don't do this, you're going to have major rust. These machined areas are going to rust up almost immediately, and you're going to have a real problem. So we definitely want to lubricate everything. Make sure you don't miss any of the cylinder bores, lifter valley area. Let's get these machined areas lubed up really good. Okay, so we're back on the bench now. We've cleaned our block, we've lubricated it. Now the next step is we have to put the crankshaft back in and recheck everything. Rarely do I do this and get everything completely clearanced the first time through. It's rare. So we're going to put this back in, put our rear cap back on, get our light, and we're going to go to town. We're going to go through the same process that we went through. So hopefully this makes a lot of sense to you guys. I definitely did the second time around here find some spots that were not relieved to my satisfaction, and so we're not done with this relieving process. I am going to have to do this again in certain spots. Of course, we're going to put the connecting rod and pistons back in just like we did, and this is round 2. So want to make sure we put that cap on, oil it up a little bit. Same process we used the first time. We definitely found some issues this second time around with the clearancing. If you remember the rod nuts that were very close to the crankshaft or to the cylinder wall there, we actually had the same problem. We did relieve a good bit of that, but what you need is 100 thousandths clearance, and we don't have it. So we're going to have to go in and do this again. So hopefully this makes sense to you. You can see I'm making some more marks here. We're starting over. Thanks for watching.
Well, hopefully this is making sense to you. I'm basically at a standstill now. I'm out of time for the day. I'm tired. But relieving the block is very critical. I'm on the second time around. I've gone through, as you saw in the videos, and I've put all 8 of the rods in, and I've remarked the places that need to be clearanced. Making sure that this is done correctly is important. There's no shortcuts to this. You have to make sure that you actually have everything clearanced in here so you don't have any kind of collisions. Better safe than sorry. It's a time-consuming process. One thing you don't want to do when you're building a stroker is you don't want to get in a hurry. You want to check and double check your clearances and make sure everything's right. So next time around, I'll probably go ahead and finish this up off camera, and we'll look at the finished product in the next video once we get everything relieved and we got the block cleaned up again. But hopefully that gives you a little bit of insight on what it takes and why, kind of some of the reasons why it's a lot more expensive to get one of these built. But it will be worth it in the long run. So I hope you enjoyed this, and I hope you learned something about this. Next time we're going to talk about compression ratio. We're going to talk about how to calculate compression ratio, because there are some things that you need to consider when you build a stroker motor. It is going to actually change your compression ratio. One of the mistakes that guys make is they will build a stroker and they don't consider that, and they end up not being able to run pump gas, because adding length to your stroke, if everything else is equal, is going to increase the compression of the engine quite a bit. And so we got to talk about how to calculate that. You're going to have to do some things. If you're running pump gas, you're going to have to actually consider what cylinder heads you put on, what combustion chamber size, and I'll give you the formula. I'll actually walk you through the formula for those of you who don't know it. I can walk you through the formula for calculating compression ratio for any engine. It's not that hard. And so we'll talk about that next time. And we'll talk about, this is a pump gas motor. And so we'll talk about how we came to the conclusion of what we did here. So hopefully you learned something this time. And until next time, stay tuned. And oh, by the way, subscribe below. Ciao.